Hello, my name is Jonathan Speed, and I'm going to talk to you about the iArmadillo, which is an infrared-based analyzer in all range of industries, but I'm going to talk to you specifically about how it can be useful for fats and oils processing. But first, I want to step back slightly from that and talk about why would you use spectroscopy to monitor a process at all? This Venn diagram shows, on the left, simple online measurements. We use these all the time. We use pH probes, temperature probes, whether we're looking at oxygen levels, turbidity, optical density. These are completely ubiquitous, even things like flow meters. They are used everywhere. They're continuous measurements, but they're parametric, which means they measure one thing. And they do this one measurement consistently, but from that we have to infer what is happening in a process. So if a temperature probe says it's hot, it's hot. If it says it's a pH probe says it's acidic, then it's acidic, but you don't know why it's acidic. At the other end of this extreme, in blue, we've got the offline measurements. These are things like HPLC measurements, chemical assays, titration, iodine value. These are direct measurements that can be made on a process, but they often require a laboratory. You've got to take a sample to a lab and then destroy it in order to measure what's going on. They're not in real time. They can be expensive. They can be very slow to measure, but they are incredibly informative. So spectroscopy sits at the middle of those two. There are loads of different types of vibrational spectroscopies. I've given webinars through the AOCS about this. I'm sure they're easy to find if you want to go and look at them. But the point being, spectroscopy directly measures a chemical reaction or a chemical concentration, but in real time, like a pH probe would. And that's why it's so powerful. It does require calibration, but there are now loads and loads of different techniques that you can use to do that. So what's the iArmadillo? Why am I here talking about that? The iArmadillo is a static optics FTIR spectrometer. That's what it is. You may have heard of IR spectrometers. They all contain moving parts. The iArmadillo doesn't. It's easy to install. The probe goes directly into the point of measurement. That probe you can see on the screen right now, put a port or a flange on the end of your probe, on the end of your pipe, and install directly inside. It communicates directly with your DCS. It sends out the data that you want to the place where you want to measure it. It's rugged, robust, reliable. You can see from the picture that it's built to last. You can hit it with a hammer and it doesn't care. I've done so myself. It's a simple contact sensing probe. The tip of that probe is a piece of diamond. The light penetrates that diamond, interacts with your sample, and we make a measurement. It doesn't sip anything inside it. It's just in the same way that a temperature probe just has to make contact. This just has to make contact. And it's stable and trustworthy. Because there's nothing inside that moves, there's nothing to drift, which means you fit it and forget. Once it is calibrated, you can just walk away. And I have instruments that were calibrated before the COVID outbreak, so late 2020, early 2021, that are still sat there, constantly chugging away, making measurements quite happily. We at Keit believe in measure, trust, and improve. These are our three kind of take-home messages. There are three key words that we live and breathe here. Measure. You need to measure constantly. If you want to improve things, if you want to make things better, you have to be measuring it. If you can't measure it, you can't control it. So the iArmadillo gives you 24/7 measuring, 365 days a year. But then you have to trust that measurement. When we build a calibration, we include what's called a trustworthiness metric. This is a simple flag, 1 or a 0. Do we believe the measurement we've just made is trustworthy? Does it fit within the calibration? If the answer is yes, then go on and do something with it. If the answer is no, we'll tell you. And we'll tell you that if we think there's a problem that needs resolving. And then using that, start to make improvements. You can reduce variation, you can enable closed loop control, and you can optimize process set points. By sticking all of that together, we can make tangible, big steps in the right direction to improve processes. I'm not going to spend too long on this, but there are loads of different examples. This is just in seed oil refining. There are other examples in renewable diesel pretreatment, in fractionation, which isn't on here. There are lots and lots of different potential use cases. but I want to talk about a few of them in a bit more detail. Free fatty acid in water washed oil. So this is real process data from a real refinery where they're measuring the free fatty acid over time. You can see this is just over a week's worth of data, and they have different batches that have come through, and they take samples off to the lab to do a titration, and we've made continuous measurements. And you can see the samples, they're not as stable as expected. The customer assumes if they take one sample at the beginning, it's going to be stable the whole way through. And you can see here there is some variation across the batch. Here's another example. This is data that we've looked at bleached and deodorized oil. So this is obviously at the back end. This is oil that is about to go for sale. And this is my favorite graph I've ever taken of fats and oils processing. Under February data, you can clearly see very, very stable sample. It's been stable over time, and then it jumps. And we see that measurement. We see that jump the second it happens. The time from here to here is 12 hours. It was 12 hours between that jump and the customer took a sample to their lab for titration. The spectrometer saw it the moment it happened. The lab saw it 12 hours later. If that doesn't show you the value of continuous real-time measurement, I'm not sure what will. And to fix that, they overcorrected. They overcorrected down to here at high cost, and then eventually got back to their correct set point. Continuous measurement would have made that never happen in the first place. Or if it had, they'd have been able to rectify it very, very quickly. But it's not just FFA. Here we're looking at phosphorus and phospholipids at the same time. This is in water washed oil inlet. So we've got non-hydratable phospholipids on the bottom of this graph and FFA on the top. A couple of things here that are quite apparent is that the FFA jumps around. Sometimes it's around about 0.5%, sometimes it's closer to 1.5%. It does jump from batch to batch. It's also not stable. We can see here it's going down through that batch, and that happens again and again. We think this is to do with stratification in the holding tank, but we're not 100% certain. But the key point is you can see that change. You can see it in real time. And phosphorus as well. That's jumping from around about 30 up to close to 100 parts per million phosphorus. The other thing is we can start to highlight when there are potentially issues with the laboratory data. With continuous measurement, you take one sample every 2 minutes. That's how often the armadillo updates. We can have a look at if that's changing. We can look at if a process should be fairly stable, with maybe some drift in the process, but not jumping about all over the place. You can then start to understand whether your laboratory data potentially has issues in. The customer here has gone back and looked at this and found that, yes, indeed, there were issues in this data. That's what real-time analysis starts to let you identify. So brief recap here, because I know I've only had 10 minutes to kind of explain to you the overall basis. The Armadillo is a robust, rugged, and reliable FTIR-based analyzer. It is a spectrometer, but once calibrated, it's an analyzer. It's designed to operate in real manufacturing plants and refineries. We didn't take a lab instrument and try and ruggedize it. We built it from the ground up to be rugged, reliable, and robust. It can be calibrated to measure pretty much anything, but examples here, free fatty acid, phosphorus. We've looked at metals. When they're dissolved up, we can see the change that has on the oil spectrum, but we can also measure things like physical properties, melting points, iodine value, color, all of it. And you can measure it all in real time. You can run as many calibrations as you like on the same spectrum and look at it all at the same time. If there is a liquid process that could be optimized, it is highly likely that the Armadillo is the tool to do it. And I'd love to talk to you about it more. If you have questions, come visit me at booth 304 if you're coming to the 2023 AOCS annual meeting. Technical questions, email me, jonathan.speed@keit.co.uk, or if you want to talk direct to our sales team, email inquiries@keit.co.uk. I really do look forward to hearing from you, so please do reach out. And thank you very much for listening.